Hello, drafters. My name is Walt from Superior Shop Drawings, and today I want to walk you through a pretty simple process of using AutoCAD to match custom molding profiles. So, for instance, let's say you worked at an architectural mill workshop as a draftsman, and one day a salesman comes walking into your office with a piece of molding that a customer had brought in. And your job was to match this custom molding so that the customer could either replace something on the exterior of their house that was damaged, or maybe it's some chair rail that they really liked in one room that they want to use in a different room. And your job is to draw up this custom molding, whether it's for a small job, short run, or a large project that's going to be several hundred feet. These days, with technology advancing, custom cutters, custom molder knives and custom router bits aren't nearly as expensive or as difficult to get a hold of as they used to be. So a lot of times when we see moderate runs of molding, it's really not a big deal to have a custom cutter made, and it's something that our customers at Superior Shop Drawings request from time to time. So I want to walk you through a pretty simple process of taking your piece of molding, your physical piece of molding, and getting it into AutoCAD so that you can prep it for a custom cutter. But first thing we're going to need, and I'm assuming you have either a cutoff or a physical piece of molding that you can either use a profile gauge and trace or trim one end so that you get a nice clean cut. But the first thing we're going to need to do is we need an image of the molding. So the one on the left is just a pretty simple piece of molding I had lying around. I took a photo of the end, which this is probably going to be more likely. You'll have this. On the right, I stuck the same piece of molding on a flatbed scanner, and I had to scan it with the lid up. That's why it looks all weird. And even though this is more accurate, I think I want to use this photo because I think it's going to be more realistic. So I'm just going to get rid of this one. So once we have our image inside of AutoCAD, you save it to your desktop, do an external reference using the IM for image command. We get our molding inside of AutoCAD, the image that we need. And the first thing we're going to do is pick a layer that you can see. I'm going to strike some construction lines. And the first one's going to be across the bottom of the molding. So as we can see, the photo is crooked, and we need a nice straight base to work off of. So I'm going to go into the rotate command, select the theoretical corner, right click nearest about here. Then we're going to do reference R from here and turn ortho off, which is F8. Pick a spot on the line, again, shift right click nearest, and then we're going to rotate the molding to my construction line. So now I'm pretty comfortable that this piece of molding is good and flat inside of AutoCAD, and as you can see, it twisted. It rotated the image quite a bit. Now I can go in and start dropping more construction lines for reference. So let's see, this one's still off a bit, but we're going to run with it. One here, put one here, put one here. We're not going to worry about this rabbit in the back because that'll be run with a table saw later on. Any router cutter that we get isn't going to do two sides. I guess suppose if you had cutter heads on the top and bottom of a molder, you could run this all in one pass. But in this case, we're going to assume that you only have one cutter head. And then I'm going to drop a reference line here to indicate this point. And then maybe I'll put one right here at the transition. So now we have a bunch of reference lines on our drawing, and it's going to be nice and easy to go ahead and to start roughing out our shape. And to do that, I'm going to use polyline, which is PL, and I'm just going to start picking points around the shape. So now A for arc, S for second point. Roughly going to pick the middle of the arc, which will give me my center point. And then I'm going to click my transition point. Then I'm going to do the same. It's still in the arc command, so we do S per second. Roughly pick the middle of the shape. Then our other transition point. L to go back to line, and then we can just go back to tracing the shape. Once we get around here and we only have one line segment left, just use C for close. And now you more or less have your molding profile. There really isn't a whole lot to it. I mean, this is a very simple piece of molding. Things can get much more elaborate, but this is what I had laying around, so that we're using this just for simplicity's sake. So now we can go through and get rid of all of the excess lines, and we have a closed polyline here. Now, I could do this section with this line, and then just trim off all my construction lines. But for years, I used a BSC Rover router, and we used BSC Works software to import AutoCAD geometry. And the machine just did really strange things with splines, and it kind of ingrained a habit in me to always use polylines because the machine never had an issue with them. So anytime I do geometry for custom cutters, any sort of CNC programming, I always use polylines. Sometimes it means a few extra steps, but I prefer the way it comes out in the end. So we have our molding profile. Now the most important part of all this is we need to scale this to size, and do that by taking our longest point. That was too giant. And I know that this dimension should be 1.25 inches across the bottom of the molding. So I'm going to scale all of it, the image included. From the back corner, R for reference, click your first point, click your end point. Now we're going to tell it 1.25 or 1.25 inches. And that's going to give us the dimension that we need across the bottom. Now, I guess we can get rid of this image. We don't really do need it later on, but it's getting in the way. Let's turn it off. This dimension should be 3/4, and it is. This should be roughly 7/16 of an inch. It is. And these were coming up about 5/30 seconds. So I really don't need to do anything. But for the sake of argument, let's assume that this needed to be 1/8 of an inch and this needed to be 1/8 of an inch. Basically, we just kind of massage the dimensions. Just by 30 seconds, not 1/8 of an inch. Until we start hitting the key dimensions that we need. Now, another very important thing to look at is I can see a lump right here, but let's make it a little more exaggerated. So let's say you're tracing over your shape, and you notice something weird like this, where there's just a sharp angle where the two radiuses come together. When you're working with CNC machines, what you draw is exactly what you get. So this little lump, even if, let's assume it were the other way. So let's say you have this instead, and you get this weird hump on the molding. If you were to send this drawing file over to your cutter manufacturer and he were to duplicate this, you would wind up with that little lump on every piece of molding that this custom cutter made. Now, that would probably cause one of three things to happen. Either you would live with it, and then someone would be very angry. Some poor guy would have to sand that hump out of every single piece of molding that this cutter ever makes, or you wind up fixing it and having a cutter remade. So just keep a close eye on some of your radiuses and your transitions. So what I like to do is just kind of massage this into a better position. And you can do that just by fiddling with the fiddling with the radiuses just a little bit until you get what looks to be a more smooth transition. And then once you're happy with it, you're good to go. So basically I can turn my image back on and see how much this affected everything. And as you can see, shifting a 32nd of an inch did changed quite a bit here and here. We'll just assume that it's right the way it is now. Or actually, we'll just go through and put those back to where they were. You are basically done at this point. You have your custom molding. You can drop this on whatever drawing you need it for. And if you need the opposite for a custom cutter, you can basically just draw it up. Draw up opposite of what you have. Here, just do a boundary, and this basically becomes my molder knife. Obviously, your molder knife is going to look different depending on the molding machine that you have and how these cutters are mounted. You may have bolt holes up here or whatnot. You could also do the same thing with the opposite for a router bit. And then here you could have a router bit for a CNC. That sort of thing. You just work with the opposite molding shape or profile shape. So that really is the key to matching custom molding profiles. Now, you are working with an image, so there is a chance that this will not come off the molding machine absolutely perfect and be a dead-on match for the piece of physical molding that you have. You have to realize that you are working with an image, and in this case, I'm working with an image that's twisted slightly because I really shouldn't be able to see down the molding here. So what you can do is, if you have a little cutoff, lay it flat on a table. If you have like an iPhone, I have an iPhone, I'd imagine Android has the same thing. There's a little crosshair in the middle that'll allow that as an indicator to let you know that it's directly above something, so you can use it as a scanner. Using that feature would help eliminate any deformities in the image when you go ahead and trace it. So I don't want to ramble on anymore. This is it's a pretty simple process, and I don't want to make it any more complicated than it needs to be. So if you have a custom molding to match, I hope this video helped you along the way. Again, I'm Walt from Superior Shop Drawings. Thanks for watching.